This is the final area of the worksheet on page 2, the surface areas, which is column F. Remember, we've assumed that the side of the cube is 1, and that means that the surface area of the cube is 6 square units. The next one to consider is the tetrahedron. There's the formula, and I'll give you 30 seconds to come up with the answer. And of course, it's 2 root 3 square units. The next one is the octahedron. There's the formula. 30 seconds. And the answer is root 3 square units. Next is the icosahedron. Now for this one, you'd better use your calculator. And I've given you also the value of phi. And that comes to 1.26, and so on, square units. Finally, the dodecahedron. There's the formula. You'll better use your calculator again. And again, you'll need the value of phi. And that's 7.89 and so on square units. That completes our surface areas. As far as comparisons go, the 3 in the middle are interesting. We see that an octahedron inscribed in a tetrahedron is half its surface area. And a tetrahedron inscribed in a cube has a surface area exactly root 3 times less than the cube, because if you multiply 2 root 3 by root 3, you get 6. Therefore the cube is 2 root 3 times the surface area of an octahedron which is in dual position. I want to demonstrate a slightly different approach to find the area of the dodecahedron. Now, because the surface area of our Platonic solids is always made up of regular polygons, we can use a formula that finds the area of a regular polygon, and it uses the apothem. There is the apothem. It's a line which is at right angles to the perimeter. But first we must find its length. And how are we going to do that? Well, we know the length of each of the sides of our regular pentagon. That is, they are 1/5. The pentagon is divided into 5 isosceles triangles. Each has a central angle of 72 degrees. Now the apothem will be that angle's bisector and form a top angle of 36 degrees, a right triangle with the base, and half the base will be 0.309. We can then use trigonometry. Tan is opposite over adjacent. Tan of 36 degrees is 0.309 over the adjacent. The height of the apothem, 0.4253. Then we can plug that into our formula. But before I do that, I recall that the dodecahedron is 12 regular pentagons. So then that will be surface area equals 6AP. And then I plug my numbers into that formula, and the answer I get is 7.89 square units. If you recall, when we used our formula, which now appears at the top, the answer was 7.89 square units. So of course we get the same answer. I wanted to demonstrate how to use the apothem. In certain circumstances, it might be easier. It's a handy formula to remember when you are dealing with regular polygons. We've now completed the worksheet, and that's really the end of the course. On the next video, I just draw a conclusion and tie up a few loose ends.